Have you ever wondered what it looks like when a single company suddenly accelerates so far past the rest of the industry that the competition doesn't even realize they've already lost? A few weeks ago, Elon Musk stood on stage and introduced Tesla's newest electric motor. Most people watching probably thought it was just another standard tech showcase. A few flashy numbers, some polite applause, and then back to business as usual. But this time was completely, terrifyingly different. What Tesla unveiled is not simply a slightly stronger or lighter piece of hardware. It is an absolute redefinition of what an electric motor can physically do. With a custom carbon fiber sleeve wrapped incredibly tight around the rotor, spinning at a staggering speed beyond 20,000 revolutions per minute, Tesla has just dragged the entire EV industry onto an entirely new playing field. This is the technology capable of launching a 2-ton family sedan from 0 to 60 in under 2 seconds. But here is the detail that should actually blow your mind. Tesla isn't hiding this secret in a vault. They completely open the patents to the world. Any automaker on the planet can read them, study them, and try to copy them tomorrow. So, why does Tesla seem so completely unbothered? Why can you hand a rival the exact recipe, knowing they still can't cook the dish? And more importantly, how is this single piece of engineering going to dictate the car you buy in the next 5 years? If you want to know how deep this rabbit hole goes, hit that subscribe button right now, because we are breaking down exactly how Tesla just cornered the market. To truly understand why this carbon-sleeved motor is causing a quiet panic in boardrooms around the world, we have to rewind to a time when Tesla was literally the punchline to an industry joke. Back in 2003, electric cars basically looked like glorified golf carts. They had zero power, pathetic range, and absolutely no one wanted to be seen driving one on a highway. The massive, legacy automakers completely dismissed the concept. Then, in 2004, Elon Musk stepped in, and he didn't just bring cash. He brought a totally different, aggressive philosophy. He believed that an electric car couldn't just be an eco-friendly compromise. It had to be the fastest, most gorgeous, violently exciting thing on the road. Starting with the original Roadster in 2008, Tesla proved that electric motors could generate raw, terrifying power. Then came the Model S, the X, the 3, and the Y. Every single product launched sent a shockwave through Detroit and Germany. Suddenly, massive legacy brands like Ford, GM, and Volkswagen were frantically pouring billions of dollars into their own EV platforms just to survive. A few years ago, industry analysts smugly declared that Tesla had finally peaked, claiming that once the real car companies entered the chat, Tesla's golden age would end. They were dead wrong. Because while the rest of the world was desperately trying to copy what Tesla built 5 years ago, Tesla was secretly building the engine of the next decade. When Musk unveiled the new Plaid motor with a carbon sleeve, the initial reaction from casual observers was, "That sounds cool, but is it really that different?" The answer is a massive yes, and it completely alters the physics of the vehicle. Let's start at the heart of the machine, the rotor. This is the spinning core responsible for turning electricity into forward motion. For decades, rotors have been made from copper and steel alloys. They work fine, but they hit a brutal physical limit. When you spin metal incredibly fast, centrifugal force pushes outward. Eventually, the metal literally begins to expand and deform, generating massive heat and instantly bleeding efficiency exactly when you need power the most. Tesla solved this violent physics problem with a concept that is simple on paper but an absolute nightmare to execute: wrapping the rotor tightly in carbon fiber. Carbon fiber, the exact same material utilized in Formula One cars and aerospace engineering, is vastly lighter and stiffer than steel. By wrapping it around the rotor, it creates an intense, constant compressive pressure known as preload. This forces the rotor to maintain its perfect shape, even when it's screaming past 20,000 revolutions per minute. This is exactly why the Model S Plaid can hit 60 miles an hour in 1.99 seconds. Until right now, those numbers only existed in $3 million hypercars like Bugatti. Tesla just handed that power to a dad dropping his kids off at soccer practice. But pure speed is just a parlor trick. The real genius here is energy efficiency. Because this carbon-wrapped rotor is significantly lighter, the motor requires vastly less electrical energy just to spin itself. That means with the exact same battery pack, the car can travel significantly further. The cooling system doesn't have to work nearly as hard, which violently extends the overall lifespan of the battery. It creates a massive positive feedback loop. The motor runs cooler, the battery lasts longer, the range increases, and your daily operating costs plummet. But wrapping carbon around a metal rotor is where the real mystery of this story begins. This is the part that genuinely amazed me when I dug into the engineering. Carbon fiber and metal expand and contract at completely different rates when exposed to intense heat. If you just slap some carbon fiber onto a copper and steel rotor, the second that motor gets hot, the carbon layer will peel off, crack, or cause a catastrophic imbalance at 20,000 revolutions per minute, which would essentially turn the motor into a bomb. To solve this, Tesla didn't just design a new motor. They had to invent a completely new, artificially intelligent robotic manufacturing system from scratch. This custom machine applies the carbon fiber with micrometer-level precision. We are talking 1/1000th of a millimeter. The AI simultaneously controls the immense tension of the fiber, the ambient room temperature, the wrapping speed, and the exact geometric angle of application. It then instantly verifies the work using high-speed laser sensors. If you want to know why Tesla opened the patent to the world, this is it. They are flexing. They are telling every other car company on Earth, we will give you the exact blueprint, but you do not own the billion-dollar, AI-driven machine required to build it. They are exposing a manufacturing gap so wide that the competition can't even see the other side. However, if we only sit here and praise the engineering without looking at the brutal reality of the corporate battlefield, this wouldn't be an honest analysis. Because the absolute best technology does not always win the war. The first glaring issue is cost. Wrapping rotors with micrometer precision is incredibly expensive. Right now, this technology is restricted to the highest-end Plaid models. The true test is whether Tesla can scale this down and force it into the affordable Model 3 or Model Y, or if it will forever remain a toy for the wealthy. Furthermore, Tesla is currently navigating a brutal financial environment. They have faced major layoffs and a vicious, global price war with heavily subsidized Chinese manufacturers. On top of that, you have the Elon Musk factor. His polarizing presence on social media and his history of wildly missed timelines regarding full self-driving have undoubtedly damaged consumer trust, especially among older demographics who prioritize stability over hype. Tesla has built the ultimate motor, but they are dropping it into an incredibly hostile market. And that market is absolutely swarming with rivals who refuse to die quietly. If you look across the landscape, the competition is fascinating but deeply flawed. Take Lucid Motors, for example. In terms of pure engineering, they are terrifying. Their drivetrains are brilliant, and they boast a 500-mile range. But they have virtually no manufacturing scale. They are a boutique brand selling to the ultra-rich. Then you have the American legacy giants. Ford proved people want electric trucks with the Lightning, but they are bleeding cash and constantly slashing production targets. GM poured $35 billion into their Ultium platform, but it has been plagued by software delays and a lack of that true wow factor. But the real monster in the rearview mirror is China's BYD. They have actually surpassed Tesla in total global EV sales. They build their own batteries, their own chips, and their costs are insanely low. But BYD has a massive weakness. They are essentially locked out of the incredibly lucrative United States market due to heavy tariffs and a massive lack of brand trust. Tesla currently has the engineering, the scale, and the brand power, all wrapped into one. But the biggest secret regarding this new carbon-sleeved motor might have absolutely nothing to do with cars at all. During the launch, Musk subtly hinted that a motor with this specific power-to-weight ratio and extreme thermal stability has applications far beyond the highway. Think about the holy grail of modern transport, electric aviation. The single biggest barrier to electric planes and VTOLs, vertical takeoff and landing aircraft, is that traditional electric motors are either way too heavy or they overheat under sustained high RPM flight. Tesla's new Plaid motor solves both of those terminal problems instantly. While Tesla hasn't officially announced plans to sell these motors to aerospace companies, the writing is on the wall. If they do, Tesla officially transcends being a car company. They become the foundational hardware supplier for the entire global energy revolution. From wind turbines to industrial pumps to the sky itself, Tesla is positioning itself to own the 21st century. So where does this leave us? We have traveled from a hacked-together Lotus chassis in 2008 to a micrometer-perfect, carbon-wrapped marvel today. But history is littered with superior technology that ultimately lost the commercial war. Just look at Betamax versus VHS. The EV market is still incredibly volatile. Battery prices are crashing, governments are changing tariffs, and consumer loyalty is fickle. Tesla has undoubtedly built a masterpiece with this new motor. But is this the final nail in the coffin for the legacy automakers? Or is someone, right now, in a lab in Detroit or Shenzhen, quietly building the exact thing that will make this carbon motor obsolete? I want to know what you think. Has Tesla truly ended the game? Or are we just entering round two? Drop your thoughts in the comments below. Hit that like button if this changed how you look at EVs, and subscribe to Crown Watch so you never miss the real story behind the tech.